All right, only 5 minutes down the trail from the trailhead, we get to the raging torrent of Centennial Brook. Actually, not at all, as you can see. It's really a very modest looking stream, but it has had a tremendous impact on the shape of this landscape, really over the last 10,000 years since the glacier retreated. In fact, the power of water and its erosive power has really shaped the landscape. We've come down the hill from campus, and if, you know, as we look back to where we're going, you can go up another side of the hill, we're in a river valley. And if you're studying landforms and the superficial geology, really the stream has been down cutting through sand, which was this ancient delta of the Winooski River where it flowed into the Champlain Sea, you know, 12,000 years ago. It's down cut through that, so some of the soils a little bit higher up are really silts and then clays. There's a lot of clay in here that we've eroded down to. And then when we get down to the stream bed itself, you can see there's actually lots of rocks. Some of them are not that waterworked around it either. They're sort of, you know, in some ways freshly exposed glacial till, which sits right on top of the bedrock that underlies this area and the city of Burlington. So it's a fantastic laboratory for looking at geomorphic processes that the river, as it engages with the landform through time, and the overall topographic relief of Centennial Woods is really a microcosm of the larger Centennial Brook watershed. That combination of the landform and the hydrologic processes that everything is draining into. As this stream, as it's meandering along this bend right here, it's doing what streams do. It's depositing its sediment load on one side, this gravel, this kind of cut area, and then it's meandering again as well as it cuts into the bank on this side as well. So a great spot to look at river meandering. Centennial Brook actually has its beginnings, its headwaters at the high point of land in Burlington at University Heights, flows down through the interstate corridor, makes its way across Main Street, and then enters the natural area here on its pathway all the way down as it meanders through the woods here, ultimately emptying out into the Winooski River, where it's carrying not only its sediment load, but the water itself as it makes its way to Lake Champlain. Chris, what are your thoughts as an environmental policy person?
Sure. In terms of human impacts on the land and on this watershed, this is a great place to study what happens in an urbanized watershed. We're in the woods here, so the stream stability benefits to a certain extent from these vegetative buffers on either side. But if you pan out and you look at a topographical map of the broader area, you're going to see a lot of impervious surfaces, rooftops, parking lots, where when all of that rain in the surrounding area hits those impervious surfaces, instead of percolating through the soil down to the water table, it runs off somewhere. And it usually runs off directly into a culvert and enters this stream very quickly. So this is a stream that during a heavy rain event can rise really quickly. It's what we would call a flashy system. And so the morphology, the shape of this stream is dynamically changing in part rapidly because of all these impervious surfaces, and stormwater inputs into this stream are shaping the way that it looks today. And you can see that there are bridges down here, there are trails down here, other impacts of human activity that have to be adjusted because this stream is going to do what it wants to do as a result of all of the storm water that's flowing down here. And in the past, where the stream has eroded into the side of the trail, trails have had to be moved, bridges have had to be moved. There's also pollution down here. This is the most urbanized area of Vermont, and we will find E. coli and other forms of pollution in this stream, which you would expect to see in an urbanized area. Yeah, is there anything else you want to add to that?
No, I think that's good. Recognizing that humans not only are having to respond by moving trails, but they've put in all sorts of stormwater infrastructure to try to sort of mitigate the fact that there's so many impervious surfaces by creating ones that the water can percolate
Yeah,
through.
so stormwater retention ponds, rain gardens, all sorts of green infrastructure has slowly been implemented over time, particularly on UVM's campus, and the whole point of that is just to slow water down and mimic natural processes and to prevent that water from rushing straight down to the stream and bringing sediment and pollutants with it.